Now, if we extend our system to include both the object and the surface, and if we assume that there is no force exerted on the object except the friction, we have the surface, and we have an object slide on the surface, and this object is subject to the friction only, and our system now is this is our system. Okay, and there is no forces from the environment. So if we define our system like this, we must have that the change of the energy of our system during the motion of the object is 0. But we know that the object will move slower, the velocity decrease. That is because of the friction. So we must have the change of the kinetic energy. But the total energy of the system, the change of the total energy of the system is 0. It means that the energy must go to somewhere, which we call here the internal energy. Okay, the internal energy. Now, since there is no other force except the friction, so it means that this term, the summation of other force, is 0. So from the previous slide, we must have that delta K is equal to the minus of FKD, which means that if we combine these two equations, we have that FKD is equal to the change of the internal energy. So we can interpret this situation that as the object moves, the kinetic energy of this object change to the internal energy of the system. As we discussed before, we can feel that the object is warmer or the surface is warmer, and that is because the kinetic energy transfer to the internal energy of the system, and this happens because of the kinetic friction. So kinetic friction, the work from the kinetic friction is the energy transfer that change the kinetic energy to the internal energy of the system. In general, if there are other forces do work on the system, in general, if there is not only the friction that exert the force, or we have the external influence from the environment to the system, we will have that the summation of the other forces, the work done by the other forces other than the kinetic friction, must equal to the kinetic energy, the change of the kinetic energy plus the change of internal energy. So by the existing of the kinetic friction, you can see that if you do work to the system, here the system is the object and the surface, you must pay something to the internal energy, and once you do that, the rest of your effort will go to the kinetic energy. Not all of your effort or not all of your work that transfer to the kinetic energy, but some of your work will go to the internal energy. Now let's consider the block sliding on the surface again, but we will include the earth into the system. So we have the surface, we have the block sliding on the surface, and we have the kinetic friction on the surface, but we extend the boundary of our system. Now include the earth. To our system, and we know that the earth will exert the gravitational force to the object. So we have to include the effect of this interaction to our system. It means that now we have to include the potential energy to our system. If there is any change in our system, in the energy of our system, we must have that the change of the energy of the system must equal to the change of the kinetic energy plus the change of the potential energy plus the change of the internal energy. Okay, because now we include the earth into our system. If we assume further that there is no other force exerted from the environment, it means that we only have the kinetic friction and the gravitational force from the earth. Okay, so we can also say that for an isolated system. For an isolated system, it means that there is no force from the environment on this system. We must have that the change of the energy of the system is zero. So it means that the change of the kinetic energy plus the change of the potential energy must equal to the minus of the change of the internal energy, which equal to the minus of Fk d, which is the work done by the kinetic friction. So we can interpret this equation that is, in an isolated system we have the object, the kinetic friction, and the earth. The change of the mechanical energy, we define this before as the mechanical energy. The summation of the kinetic energy and potential energy is a mechanical energy, and the change of the mechanical energy will go to the internal energy, which is equal to the force with the work done by the kinetic friction. So this is we can experience in our daily life. When you do some work, like when you want to move a box of something, you have to do some work, okay, and you have to pay that to the friction, other than you increase the kinetic energy or the potential energy. Like if you slide the object along the incline, if there is no friction, you know that the work done will go to the kinetic energy or the potential energy. But if there is friction, you have to pay something to the friction, and what left will go to the mechanical energy.